Hey guys, here we are, another week of virtual learning. Yay! Said no student ever. Okay, so this week you're going to be learning about surface water. So let's kind of revisit last week's introduction. We talked a bit about the water cycle, and I showed you in a video how little, when we talk about freshwater versus saltwater, our freshwater resources are so insignificant compared to saltwater resources. They're all part of the same water cycle, but obviously freshwater is cause for concern because what do we all need for survival? Water. Okay, so the water cycle describes the interactions between water and the earth, which is the geosphere, the atmosphere, which drives changes in heat energy and distribution of water, and then the biosphere, which is all life on Earth. So if we look back at our breakdown, I think I said last week in the video that oceans represent 97%. I was a little off, but that's okay, which leaves us with about 3% of freshwater resources. The vast majority of those freshwater resources are locked up in glaciers and ice sheets, so obviously not accessible to you and I, which leaves us with about 30% or 1/3 of an already 3%, so that's 1% of groundwater and surface water resources. So again, 1% of all resources on Earth are freshwater. Most of that is trapped underground in aquifers, and then a small percentage is found on the surface of the Earth. And so, as you guys know, water cycles through the Earth system. It evaporates due to heat energy from the sun and transfer of energy from the oceans, plants. It evaporates from soil, and it moves up through the atmosphere. As it rises through the atmosphere, obviously it cools and condenses and falls again as precipitation. And as you learned last week, that precipitation will infiltrate the soil and then rock. When the soil becomes supersaturated, as it has in recent weeks in central Ohio, it will run off the surface, and we call that surface runoff, obviously flooding. And that runoff will eventually end up back in the water cycle in streams and other watersheds and whatnot. So here it is. As you can see here, I just described it. So some of that water infiltrates into the ground and is stored as groundwater, and then some of it runs off into streams and eventually the ocean, and then we start again, right? So all water on Earth has been here since, for billions of years, right? It's trapped within the Earth system because of gravity, and, don't let that get you down. Get it? Anyway, moving on. So why is there a difference between runoff and infiltration? Obviously, as you guys are fully well aware, we have seasons where we have above average precipitation, and then we have seasons of drought. The western United States is now in a decade-long drought, which we'll talk about this week. And so those changes in the amount of rainfall affect how much water infiltrates as groundwater, and then how much water obviously runs off the surface and feeds our streams and whatnot. So when the surface is impermeable or saturated, runoff is the dominant source of surface water. And we see this particularly during the spring season when we have heavy rainfalls. We have a lot of runoff in urban areas where the ground is generally impermeable. We saw this a few years back with the heavy hurricane season in Houston. Houston, Texas is basically a giant parking lot, and they received about 40 inches of rain within a matter of days, and the whole city was underwater. So this is something that city management and engineers obviously have to concern themselves with. And it's particularly true now as our climate is warming and we're seeing above average temperatures in the Gulf of Mexico and the Atlantic Ocean, where most of our evaporation, right, comes from. So more evaporation or increased rates of that lead to increased amounts of precipitation. So this can be problematic. Runoff can eventually feed into a series of gullies or little creeks that eventually braid together into a stream channel. And a stream channel can be varying in size, but it carries a substantial amount of water and also sediment. Rivers obviously are a bit bigger than stream systems, so we'll talk about the difference. The videos that I filmed along Spring Run, this is a stream, and so definitely not the size of, say, like the Scioto River that runs through Dublin, Ohio, and then downtown Columbus, or the Olentangy that runs through Worthington and Columbus, or Alum Creek in Westerville. So those are larger river systems that have a lot of tributaries, including the stream that's in my backyard. And so what drives stream flow? Primarily gravity, right? So water's always going to run downhill, which makes perfect sense. And that area that's defined by topographic highs is called a watershed. Okay, so imagine you have two mountainous areas and then a valley in between. So all water is going to run downhill into that valley. So the western slope of one hill will have streams that feed into the valley, and the eastern slope of the other adjacent hill will have streams that run into the same valley. So that area is called the watershed. And we have two primary, well, I would say two peaks or ranges that define watersheds within the United States. In the western part of our country, it would be the Rocky Mountains. In the eastern part of our country, it would be the Appalachian Mountains. And those two topographic highs on either side of the country define where water will flow. And they're also called continental divides. So the Rockies are like 14,000 feet high out west. Anything that falls on the east side of the Rockies will flow into the Mississippi watershed, which drains into the Gulf of Mexico. Anything that falls on the west of that peak, 14,000 foot peaks, will flow out into the Pacific. And then opposite, but same scenario in the Appalachian Mountains, anything precipitation that falls on the east in the Appalachians will flow into the Atlantic. West of Appalachians, which includes central Ohio, will flow down into the Mississippi watershed and out into the Gulf of Mexico. So continental divides kind of split the drainage area here in the United States. And here's what that looks like. Okay, so if we were just defining, like I said, this would be like the Appalachian Mountains here on the eastern U.S. This would be like the Rocky Mountains. And we would be in this area, not as topographically defined, but you get the idea. And then this would be obviously the Mississippi River that drains eventually out into the Gulf of Mexico. So these topographic highs define drainage area. I'm going to stop here, make this kind of the first of a series of enlightening videos about stream flow and surface processes. Guys, I miss you. There's no jokes. It's boring. I'm so sorry. We're going to continue on in video number 2, stream flow, surface processes. Stay tuned.